Hi students, a hearty welcome to all. This is Gopal from Department of Chemistry, Bharathidhasanar Matric Higher Secondary School, Arakkonam. Today we are here to discuss the topic thermodynamic principles of metallurgy in 12th chemistry, the first unit. What is thermodynamic principle of metallurgy? First, we know the del G value as del H minus T del S. The del G value is the value of construction or non-construction of the material. We can find the construction energy of the material by the del G value. So, the thermodynamic principle of metallurgy discuss as the formation of metals from metal oxides and the reduction of metal oxides, and what are the suitable agents we can use in reduction of metal oxides. All the topics will be discussed in the thermodynamic principles of metallurgy. For example, one of the metal reducing agent, the carbon, the reducing agent carbon can be used as, when the carbon reacts with oxygen, the oxygen present in the metal oxide, the carbon reacts with oxygen, it can form easily the carbon dioxide. So, carbon here act as a reducing agent. For another example, carbon monoxide is also formed. When carbon reacts with oxygen, you can form carbon monoxide. 1 mole of oxygen molecule can contain 2 oxygen. So, you can form 2 carbon monoxide and 2 numbers of carbon is reacted. So, here carbon also acting as a reducing agent and forms carbon monoxide also. Carbon monoxide can further oxidize to form carbon dioxide. It can react with oxygen and it forms carbon dioxide. The 4 numbers of oxygen can form 2 numbers of carbon dioxide. So, which reducing agent is suitable for the metal reduction? That can be identified by the Earlingham Diagram and thermodynamic principle of metallurgy. I will say about the Earlingham Diagram. At first, the thermodynamic principle of metallurgy says that the del G is positive on increasing the temperature, the value of del Ts would be increasing. So, when the del G is positive, the del G is opposite to the del S. Del S is positive means the del G will be negative. So, del G is opposite to the del S. The del S means the change in entropy. S means entropy. So, del S is the change in entropy, and the temperature T is the temperature that rises in the metal reduction, and del H, it is the enthalpy change. So, change in enthalpy. From these values we can find the del G. So, in this reaction the del G is opposite to the del S. When the del S is increasing, the temperature increases and del S attains the positive sign. As the opposite, del G attains the negative sign. So, this is the thermodynamic principle of metallurgy. Let us see here, from the thermodynamic principle of metallurgy, we can find a suitable reducing agent and we can see the changes in the del G values by the changes in the temperature by only the Earlingham graphical diagram. The Earlingham diagram is given by Johann Thomas Earlingham. He is a scientist in he can find the deep innovations in the metallurgy, and his diagram is called as Earlingham diagram. In Earlingham diagram we have the del G naught value in the y axis. The del G naught is equal to minus RT ln Kp. This value is given in the y axis, and in x axis the temperature ranges is given. When the temperature increases, as per the metal oxide formation is occurred, and the further reduction of metal oxide is also obtained. The del G naught values get more negative when the temperature is increases, and as the temperature increases further away, the del G naught value attains the 0, and as the temperature increases, the del G naught value is moreover increases to the positive. when the del G naught values attains the positive, the metal gets the free energy state. What is the difference between free energy state and the normal combined state? When the metal is being in the combined state, it will be stable, and with the other molecules it can form the complex. So, it will be not in a free energy state. But when the metals attain the del G value, it attains the free energy state. That means the metal will not combine with the other elements, and it is obtained alone is the free state. So, it is the free state. So, by increasing the del G value, we can collect the metal alone. That is the reduction of metals. Metals will combine with oxygen and forms metal oxides. The reduction of metal oxide means the metal releases the oxygen and metals alone collected. So, this principle is involved in the Earlingham diagram, and we go to the concept. As per the Earlingham diagram, we can find the standard free energy changes. The free energy will be represented by the symbol del G. The changes in the free energy is done by the changes in the del S in opposite side. The changes in del S is done by the changes in the temperature. So, by changing the temperature, we changes the del S values and the del G values. So, the changes in the del G values give us the formation of metal oxide and the reduction of metal oxides as per the rule. So, what is the use of the Earlingham diagram and what can be observed from the Earlingham diagram? Now, I say that Gibbs free energy only observed in the Earlingham diagram, and it is given by HJT, Harold Johann Thomas Earlingham. So, HJT Earlingham gives the Earlingham diagram, and this diagram is called as ED, so source representation. And by the sound based of considering the choice of reducing agent, its main use for this Earlingham diagram is to find the choice of reducing agent, which suitable reducing agent is suited for the reactions. It can be found by the Earlingham diagram, and this diagram helps us in predicting the feasibility of thermal reduction. The thermal reduction feasibility also determined by this Earlingham diagram. So, from the Earlingham diagram we can change the standard free energy change, that is the indicate the variation of standard free energy changes. Stop. From the graph we can know about the formation of metal oxides. From the graph we can see that the slope going upwards represents the formation of metal oxides. By increasing the positive value of del G or reducing the negative value of del G, the slope increases upwards and the metal oxide is formed. The formation of metal oxides is indicated by upward slope. Upward slope indicates the formation of metal oxides. This is used in the Earlingham diagram, and the metals like Ag, Hg, it will attain the variation of standard free energy and formation of their oxides. Finally, the value will be attained in 0. So, greater than 0 at high temperature only it will form a metal oxides, and any metal oxide with lower standard free energy change is more stable than another metal oxide with higher standard free energy. So, lower free energy state and higher free energy state metals will changes the oxygen atom present in the metal oxides. For suppose if the first metal oxide releases the oxygen atom, the released oxygen atom further help us to form the metal oxide for another metal atom. So, the released oxygen atom combined with another metal to form a metal oxides. So, the interrelated reactions is occurred in the Earlingham diagram. Let us see here. But the Earlingham diagram is useful to find the suitable reducing agent, and it is useful to find the difference in the del G value, but it has two limitations also. What are the two limitations? First one, the reactant and products are considered to be in equilibrium. As per the Earlingham, the reactions obtained in the diagram is in equilibrium, but it is whether true or false, it cannot be considered in the Earlingham diagram. So, finally the reaction is true or false is not said by the Earlingham diagram, so which is not true. So, all the reactions not in equilibrium, and is another limitation is the rate of the reaction. In the Earlingham diagram, the rate of the reaction is not given. So, we cannot find the rate of the reactions obtained in the Earlingham diagram. So, the rate is not given, it is another limitation. First limitation is equilibrium is 0, equilibrium is obtained in the reactions is not true, and the rate of the reaction is not given in the Earlingham diagram, it is the second limitation. And let us consider the electrochemical principle of metallurgy. First we see that thermodynamic principle of metallurgy, now we go to the electrochemical principle of metallurgy. What is the electrochemical principles? In the electrochemical principles, we can see that the electrochemical reactions, every electrochemical reaction is obtained by considering a container, it contains two electrode potential rod, and the positive end is called as cathode and the negative end is anode, and the cathode attracts the positive ions and the anode attracts the negative ions. Finally, it is collected alone. So, this is the electrochemical process. In this process, we can find the del G naught value. The del G naught value is minus NFE naught. Del G naught is a standard Gibbs free energy change, and N is the number of electrons that moving in the reaction, and F is the Faraday constant, and E naught is the electrode potential of the reaction. The potential of the electrode is E naught. Finally, F is the Faraday constant given by the Faraday. So, this is the calculations based on the electrochemical principle. In the electrochemical reactions, I show you one of the reaction. Copper oxidizes the ferrous ion. Let us see here. First, copper 2 plus ion, it get reduced into copper metal atom, and it oxidizes the iron metal into Fe2 plus iron 2 plus ion. So, in these reactions, the copper attracts the two numbers of electrons from iron, and the iron loses 2 electrons to form the Fe2 plus. So, the movement of electrons is measured, and number of electrons moved in this reaction N is equal to 2 numbers of electrons. So, the value N is 2, and the constant value of Faraday is considered to be F, and the potential of these electrodes is calculated as E naught. From these values we can find E naught, F minus N. So, finally, we can get the del G naught value. So, this principle is used in the electrochemical process. For one of the example for the electrochemical process, we can see that Hall process. This process is suitable for producing the aluminum from the bauxite, aluminum oxide, metal oxide. For example, in anode, the oxygen metals loses the electrons, the oxygen 2 minus ions gain the electrons to form the oxygens. The cathode reactions includes the aluminum 3 plus accept the electrons and forms the aluminum metal. So, the metal aluminum is collected in the cathode by the reduction reaction. Overall, the aluminum oxide is reduced into aluminum and the oxide is removed. This reduction reaction is obtained in the electrochemical process of aluminum. This process is called as Hall's process. So, in this process we consider the two reactions, one is obtained in the anode, that is oxidation, another one is obtained in the cathode, that is reduction. In anode, the oxygen obtains electrons and forms as oxygen molecule. So, the oxygen is removed alone, and in cathode the aluminum metals only collected, aluminum accept the electrons from the oxygen and get into aluminum metal. So, the overall reaction is aluminum oxide, that is aluminum metal oxide reduction get reduced and removes the oxygen, the finally aluminum is obtained. This is the aluminum electrochemical process, which this cathodes will be in carbon anodes, and anodes are also a carbon cathode, and the molten aluminum precipitated down is collected alone. This is the experimental diagram of Hall's process. The overall reaction can also be written as the aluminum oxide takes the carbon, and the carbon takes only the oxygen present in aluminum oxide, the aluminum is reduced alone, and the aluminum oxide can be separated into aluminum 3 plus ions and oxide 2 minus ions. So, only aluminum only present as a ion that want electrons to form a aluminum metal atom, 3 numbers of electrons is substituted by aluminum 3 plus, finally aluminum metal atom is collected alone. So, finally the metal aluminum is extracted. The carbon can take the removed oxygens to form a carbon dioxide or carbon monoxide. The carbon can take oxygen to form, one is carbon monoxide, another is carbon dioxide. By the way, we can reduce the metals, and the removable carbon monoxide and carbon dioxides finally kept the aluminum alone. This is the Hall's process. See that. So, we discussed about the concentration of metals and extraction of metals. By the concentration of metals, we get the ores as a pure form, and the pure ore is converted into metal oxide by the calcination, roasting. This process also considered in the Earlingham diagram and thermodynamic principles, electrochemical principles also. So, finally we need the metal purification, that is refining. The refining of metals can done by the liquefaction. One of the process of refining is liquefaction, another one is distillation, and third one is electrolysis. First one we see the liquefaction process. In this process, the crushed metal is poured into the chamber, and the chamber is heated, the melted metal atom is collected alone. Finally, the melted metal atom collected is pure form. The liquefaction process contains only low melting point metals. Here you note the point, only low melting point metals, because to collect the metals in melted form, we need to use the low melting point metals. So, one of the examples for low melting point metals are tin, lead, mercury, bismuth. These all are present as impurities in the low melting point metals. Tin, lead, mercury, bismuth, that impurities will be present in low melting point metals, and it can be collected alone. This process is called as liquefaction. Or another process is a distillation process. Here also we have metals and impurities, that is impure metal. The impure liquid metal is evaporated, and the low melting point metal only melted and collected alone. This process is distillation. By the process of distillation, the low melting point impurities are first evaporated, and low melting metals are first distilled by the distillation. And electrolysis process, in this process, as we discussed before, we use two rods, that will be cathode and anode. The cathode and anode is used. The anode attracts the impure copper metal atoms, and the pure copper atoms are collected in the cathodes. Finally, the pure copper metals are collected alone. So, this process involved in the electro refining process. And another one is a final process, that is the zone refining process. It is a metallurgical process and mechanical process. In this process, the impure and pure metals is collected as a rod form, in which the mobile inductive effect conductors is used above the rod. It heats the metal atom. When it heats the metal atom, by the way the metals are heated and attains the melting point level, and finally the before melting point level is obtained and the impure metals are moved in the corner. So, finally the pure metals are heated and being in the pure form, and the impure metals are collected in the end of the rod. So, this method is used in the zone refining process. So, this process is very high purity ore obtained by this method. In this process only high purity method ore is obtained. So, this process is the advantage process also. And our last process is vapor phase method. In this process, the metals in being in vapor phase only used. For example, one of the process is Van Arkel method and another one is a Mons process. In the Van Arkel method, the titanium metal forms titanium tetraiodide by reacting with iodine molecule. When Ta reacts with iodine molecules, it forms titanium tetraiodide, and at high temperature the titanium iodide also removes the iodine metals, and finally titanium in pure form is obtained. So, this method is included in the vapor phase method. And Mons process, nickel reacts with carbon monoxide to form carbon monoxide nickelate. So, it's also in a high temperature, the carbon monoxide is removed alone, finally the nickel is obtained. So, in this process we have nickel in the reactants and the nickel in the products also. So, both are the same. So, what is the difference between the reactant nickels and product nickel? That is, the nickel in the impure state is first collected and finally obtained form of nickel is a pure state. So, only we use the same product and same reactants in this reaction. So, it is one of the refining or purification method for the metals. Okay, students. So, in the chapter we see that minerals, metals, concentration and extraction, purification in this process. By the way of Tamil, I can said you, இந்த பாடத்தில் நம்ம மெட்டலர்ஜி பற்றி படிச்சிருக்கோம். மெட்டலர்ஜினா மெட்டலை பற்றி நம்ம படித்தோம். இதில் பார்த்தீங்கன்னா மினரல்ஸ், ஓர்ஸ் அண்டு நம்ம கான்சன்ட்ரேஷன் ஆஃப் ஓர்ஸ் பற்றி பார்த்துருக்கோம். மெட்டல்ஸ் வந்து மண்ணில் இது நேச்சுரலாக கிடைக்கிது பார்த்தீங்கன்னா மினரல்ஸ்னு நம்ம சொல்கிறோம். ஓர்ஸுங்கிறது வந்து மெட்டல் வந்து அதுலேருந்து தான் நமக்கு கிடைக்கிது, அதனால் ஓர்ஸ்ன்னு சொல்கிறோம். மினரலுக்கு ஓருக்கு ஒரு டிஃப்ரெண்ட் என்னென்னா, மினரலில் வந்து ஹை பர்சன்டேஜ் மெட்டல் இருந்துச்சுன்னா அதை நம்ம ஓர்னு சொல்கிறோம். மெட்டலில் வந்து ஓர்லேருந்து நம்ம எடுக்கணும்னா 3 ப்ராசஸ் நமக்கு தேவைப்படுது. ஒரு ப்ராசஸ் வந்து கான்சன்ட்ரேஷன், அனதர் ஒன் எக்ஸ்ட்ராக்ஷன், தேர்ட் ஒன் வந்து ரிஃபைனிங், பியூரிஃபிகேஷன். கான்சன்ட்ரேஷன் ப்ராசஸில் ஒரு பியூரான ஓர் மட்டும் நம்ம எடுக்கிறோம், ஃபஸ்ட்டு ஸ்டெப். அதுக்கு அடுத்த ஸ்டெப் அந்த ஓர்லேருந்து மெட்டல்ஸ் வந்து மெட்டல் ஆக்சைடை நம்ம கலெக்ட் பண்ணணும். அதுக்காக தான் நம்ம வந்து கால்சினேஷன், ரோஸ்டிங் ப்ராசஸ் மூலம் மெட்டல் ஆக்சைடு எடுத்தோம். ஃபைனலி நமக்கு மெட்டல்ஸ் மட்டும் தனியாக கலெக்ட் ஆகணும். அதனால் லாஸ்ட் ப்ராசஸ் ரீஃபைனிங் மூலமாக பியூரான மெட்டல் நம்ம எடுத்துக்கிட்டோம். ஸோ இந்த ப்ராசஸ் எல்லாமே இந்த பாடத்தில் முடிஞ்சது. ஓகே, த ஸ்டடி மெட்டீரியல்ஸ், கொஸ்டின் பேங்க் and self-assessment question paper also given in the description. You need to write the self-evaluation test and send us me for corrections. We will come and check the self-assessment test. So be sure whether you complete the self-assessment test. Thanks for making time to watching this video. Thanks you. நளினி அமிர்தாவோட ஃபாதர் ப்ரீகேஜிலேருந்து 8th ஸ்டாண்டர்ட் படிக்கிறாங்க. இப்போ
காலையில் 5:30 to 6:30 வந்து கிரவுண்ட் ரன்னிங் ப்ராக்டிஸ் பண்ணிவிட்டு பாடி எக்ஸசைஸ் பண்ணிவிட்டு அப்படியே ஸ்கூல் அட்டன் பண்ணிவிட்டு மத்தியானம் மேலே மதர் தெரேசா அகாடமிலையும் ப்ராக்டிஸ் பண்ணுறாங்க, மெட்ராஸில் எம்இஎம்லும் ப்ராக்டிஸ் பண்ணுறாங்க. நேஷனல் லெவலில் வந்து கோல்டு அடிச்சிருக்காங்க.
நான் அரக்கோணம் பாரதாசனம் 6 வருஷமாக டேபிள் டென்னிஸ் கோச்சாக இருக்கேன். ரன்னிங் பண்ணால் ஸ்டடீஸ்லேயும் சரி ஸ்போர்ட்ஸ்லேயும் சரி